Okay, here we are for day 1. Another derivative rule. We are looking at when you have an x function divided by another x function, so that's a quotient rule coming. So derivative of a quotient. So you're going to be looking for two x terms in your function, one in the numerator, one in the denominator. F of x, so some function of x divided by another function of x. All right, so our derivative rule, which you can put on your blue sheet, write both of these next lines. So I'm just going to use u to represent the numerator function, v to represent the denominator. If you're going to do derivative here, y prime equals, you take the derivative of your numerator, multiply it by the denominator, subtract the numerator times derivative of the denominator all over denominator squared. Okay, all we're going to do is practice this today. Lots of algebra, exponent rules, just be careful. So we'll start easy and build our way up. So number 1. Let's go with y equals 7x minus 2 over 3x plus 4. So notice the two x terms. You have to do quotient rule. You can't just do derivative of top over derivative of bottom, call it good. Quotient rule has to work, has to apply. So, derivative of the top right here is 7. That's a 0. Multiply by the bottom. Minus, keep the top. That's your u term. Derivative of the bottom is just right here. It's going to be a 3, and then that turns into 0. And then all over the bottom squared. Okay, calculus is over. We're just going to use algebra and simplify. So we're going to be distributing a 7. That'll give us 21x plus 28. Here I'm going to be distributing the 3 and the negative. So think of it as a negative 3 going in. So it'll give us a negative 21x. And then a positive 6. Denominator doesn't change. So 21x's cancel out. 28 and 6 gives us 34 over 3x plus 4 squared. And don't you dare try to cancel that 4 and 34. Oh, how did I get a 34? Or 4 and, yeah, for 34. Okay, we're good. Number 2. Let's throw some trig at you. Y equals x plus 2 over cosine 3x. So again, x function divided by x function, think quotient rule. So our derivative up here, derivative of x is 1, plus that turns into 0, so it's just a 1. Derivative of cosine 3x, remember trig function first, that goes to negative sine. Never change the angle. Now we multiply by the derivative of the angle, which is just a 3. No canceling to do. The only simplifying is to float this 3 to the front. Maybe float the negative up to the top. Negative 1 over 3 sine 3x. Okay, number 3. We got d dx. Remember, that's just saying take the derivative of this next function with respect to x. Let's go cosine 2x over x. So with this notation for derivative, all we need to do is put an equal sign. I see x term divided by x term, quotient rule. So starting with the numerator, derivative here is negative sine 2x. Keep the angle the same. And now we multiply by the derivative of the angle. And so all of that was your u prime. Now we still got to multiply by the denominator. So there's our u prime times v. Minus, we will keep the top the same, cosine 2x. That's our u. Times by the derivative of the bottom is just a 1. All over denominator squared. And just a little simplifying. This 2x floats to the front with that negative. The 1's just going to not change anything. All over x squared. And if we're looking for any simplifying, I have just x squared in the bottom. I have an x here, but this term over here in this basket for me to cancel. The x that's here is on the angle, so we are not allowed to cancel there. So that's done. Here we go. I might even start a new page because it's going to be a lot of lines. Here's lots of algebra coming. Number 4. Y equals the quantity 4x plus 3 to the 6th over 2x minus 5 cubed. Okay, again, x term over x term. I see outsides and insides. We got lots going on here. But we definitely have to follow quotient rule. So, quotient, we're going to start with the derivative of the top, which has an outside and an inside. So forget about the bottom. We're going to start out here with our power rule. So the 6 will come down. We're going to keep the inside the same. Subtract 1. So that derivative's done. Now we still have to multiply by the derivative of the inside, and it's just a 4. So it took all of this to do u prime. And now we still have to multiply that by the denominator. And we'll subtract. Oh, I shouldn't have scribbled that out so much. I need the numerator, 4x plus 3. Originally it had a 6 there. And now same thing on the bottom, outside times inside. So the 3 is coming out in front. 2x minus 5 squared. Inside derivative is 2 because of the 2x. And then that's all over the bottom which is 2x minus 5 cubed, but we have to square that. Okay. Now we've just got our simplifying to do. And when we have this fraction, we do want to reduce or cancel any common factors. So we've got two options. We can basket factor the top and then cancel, or we can cancel first and then basket factor. I kind of like canceling first because then there's less to keep track of. So the only simplifying you want to do first is this power to power here, and know that that's going to be 2x minus 5 to the 6th. The 3 times 2 is going to give us a 6. So what I want you to do now if you're going to cancel, is look in all three baskets. And the only thing in the denominator are these 2x minus 5s. 2x minus 5, we've got 6 of them. So look in this first basket. First basket has 3. Second basket has 2. Bottom has 6. So instead of taking those 2 out and then canceling later, let's just cancel them right now. So all of these are gone. 2 of these are gone. We're left with 1. I have 6, but I canceled 2. So when the least amount is what you have to take away from everything. And that'll be it for canceling. So now simplifying this first big basket, the 6 and 4 find each other for a 24. We've got a 4x minus 3 to the 5th, and then we've got a 2x minus 5, and that's to the first. Over here, 2 and 3 find each other for a 6, and I've got a 4x plus 3 to the 6th. All over 2x minus 5. Oh, I did that wrong, didn't I? I see it now. I canceled 2. I want 4 left, not 2. 4. I said I wanted to cancel 2 and I wrote 2. Okay, the only thing left to do is basket factor. Remember, we basket factor when we don't have any trig functions, so we're going to basket factor that numerator. So first of all, I see a 24 and a 6. I'll take out a 6. And I have 5 of these in the first basket and 6 here. So 4x minus 3 to the 5th. That's going to be it. So that will leave a 4 with a 2x minus 5. And that will leave one of these. Plus 3. All over minus 5 to the 4th. And the last bit is to simplify in here. So we can distribute. That'll give us an 8x minus 20. Distribute this. Minus 4x minus 3. Not allowed to distribute the 6 in there. You can only distribute in when the power is 1 on your binomial, not when it's anything but 1. So this stays 6. 4x minus 3 to the 5th. In here, the 8x minus 4x will leave us with 4x. We'll have minus 23 over 2x minus 5 to the 4th. So, just got to take your time, be careful with the algebra. All right, our last one is going to be done 2 ways. Number 5. F of x equals 4 over 3x to the 5th. And we want to do this 2 ways and show that they're equal. Okay, every one of these examples, I always pointed out, numerator has an x, denominator has an x. Well, that's not true here. Only the denominator has an x. But the quotient rule can still apply here. So, when there's just an x in the denominator, we can do quotient rule. So we'll let that be our method 1. The other method, we've done this problem before. We just had to rewrite it. We had to bring the x up out of the denominator and then use one of our other rules. So that's going to be our method 2, is going to be to rewrite. So in the previous chapter, you couldn't leave this down here and do derivative because we didn't have quotient rule. Now you can leave it here and do the quotient rule. So we'll do both ways and show that they come out the same. So f prime of x equals, so quotient rule says take the derivative of the numerator. Well, the derivative of 4 is 0, multiplied by the bottom. That's going to zero out, and then we're going to subtract. We're going to keep the numerator. Multiply by the derivative of the denominator. That's going to be, that's a power rule, 15x to the 4th. And then that's all going to be over 3x to the 5th squared. So, calculus done, algebra. So we will have a 0 here, so that's all going to be gone. Here we've got a negative 4 times 15, so we've got a negative 60x to the 4th. In here, we have to square the 3. That's going to turn into a 9. And then x to the 5th to the power of 2, you multiply, you're going to have x to the 10th. So now it's just a matter of reducing your fraction and canceling some x's. So 3 goes into 9 3 times, into negative 60, negative 20 times, and we can cancel out 4 x's. So these are going to be completely gone, leaving 6 of them here. So we've got a final derivative of negative 20 over 3x to the 6th. Okay, so let's get the same answer with the rewrite. So we have f of x equals 4 over 3x to the 5th. That's what we're starting with. So this is still going to be f of x. I'm going to rewrite it so I don't have to do quotient rule. That means this x term has to come to the top. So first of all, I want you to see that we can separate the 3 from the x to the 5th. I can write this as 4/3 times 1 over x to the 5th. That's still going to give me 4 over 3x to the 5th. This is not a necessary step. I just wanted to show you where this rewrite's going to come from. So 4/3, now I can bring this x to the 5th up to the top and just give it an unhappy exponent. So, didn't need this middle step. All we did was take this and bring it up. So now, notice I've called that f of x because I haven't done derivative yet. Now I'm ready for derivative. All I've got to do is a power rule. So the negative 5 gets multiplied by the 4/3. That'll give me negative 20/3. X subtracting 1, that's going to give me negative 6. Well, look how close I am. All I've got to do is make this exponent happy, and I'm going to have this. So we'll keep the negative 20, keep the 3 down here. We're going to make that happy in the denominator. Now they are the same. And there it is.